Hi Bruno, how are you?
I'm fine, and you?
Fine, thanks. I know that you are working on innovative solutions for enterprise based on software-defined network paradigm, isn't it?
Yes, it is.
Good. Talking with enterprises IT managers, I see a growing interest on enterprise SDN. With a programmable network approach, they expect to implement a more flexible infrastructure capable to manage network resources depending on users' application requirements. So I'm wondering if you could help me on this.
Sure. Could you please better describe the actual enterprise context and needs you are talking about?
Basically, I'm thinking of large enterprises with several branches. Usually, they have limited bandwidth in the peripheral sites, and at the same time, they normally deal with a bunch of applications for internal communication, either IPv6 based or peer-to-peer or WebRTC. The bandwidth constraint is especially critical when video services are involved. Heterogeneous application can negotiate the bandwidth they need, and this often results in a poor quality of experience.
Stefano, you are talking with the right person. The solution I'm working on addresses exactly your needs. As you can see in the slide, we have identified a large enterprise scenario with multiple sites and several unified communication applications with the centralized call control or even peer-to-peer. If you want to dynamically control audio and video calls in such a complex scenario, keep into account of IP network resources availability, you need a centralized management system that interacts with both IPv6 or web application servers and the IP network through an SDN controller, like the Cisco EPIC EM represented here, which collects traffic data and implements QoS configurations. This system is the Italtel Call Admission Manager.
Very interesting. But you have to keep in mind that IT managers are afraid of being forced to upgrade their network to support SDN protocols. What could you tell me on this concern?
Take into account that this solution can support the interaction between the controller and the network elements, like routers and switches, via CLI, in order to make the transition towards SDN implementation easier.
Great! Can you show something to me right now?
Yes, sure. I will give you a brief description of the demo I'm going to present you in the following slide. We have simulated an enterprise with 3 sites: Milan, the headquarters where the applications are installed, and 2 peripheral sites, Rome and Bologna, where end users are located. We utilize 2 IPv6 technologies to manage video calls among end users, a Cisco Call Manager and FreeSwitch. Italtel Call Admission Manager interacts with the IPv6 to admit or reject calls, depending on the network conditions monitored through the EPIC EM SDN controller. We use a traffic generator to simulate network congestion. Through the Italtel Call Admission Manager, it is possible to apply different policies in order to improve quality and maximize the end-user experience.
Bruno, could you please explain the interaction between Call Admission Manager, EPIC EM, and the IPv6?
The interaction between the Call Admission Manager and the controller is performed via REST APIs, and with IPv6 can be performed in SIP, or, if available, with the vendor-specific APIs.
Good. Please, show me the demo now.
Let's start with the demo. The first interface is the EPIC EM, showing the wide area network that we are simulating with the 3 sites and the different hosts, the application servers, IPv6, and the hosts. 2 hosts are traffic generators and 2 are the end users. This interface is the Call Admission Manager. We can see that at the moment in the channel there is 1 call per second generated by the traffic generator. Here we can see the policy that can be set. At the moment is disabled. We have 3 different policies: disabled, that is best effort; audio only, that is, only audio calls are admitted, and strictly, where if there is no bandwidth, no calls are accepted. The demo will be performed in different phases. At first, we will simulate a call with the current situation, that is a free channel, and we will see that the video quality will be good. Then we will generate a congestion situation, saturating the channel, and we will test the 3 different policies. And we will see the different behaviors depending on the policy that is set. So Stefano, let's start with the first call.
Sure. Okay. So I'm using Japper now.
Yes.
Hi Andrea. Hi.
Yes, as you can see, the quality of the video is very good because there is no congestion in the link. So, as we can see from the graphical interface, the call has been admitted and routed without any problems. Now, let's start saturating the link, generating more calls per second. It will take a while to saturate the link, and at the end, we will have a completely saturated link. As we can see, after a few seconds, the channel has been saturated by the calls generated by the traffic generator. So now we can start trying the different policy. The first one that is configured is disabled, it means best effort. So please generate the call and we will see that the result of the call will not be so good.
Okay. So I'm using now the Zoiper client.
Yes, with FreeSwitch IPVX.
Hello, Stefano.
Hi Andrea.
So how is the quality of the video?
Not so good. Very poor quality.
Yes. So in order to avoid this kind of situations where the quality is not good, it's necessary to apply a policy to manage the calls when there is not enough bandwidth to support all the calls. So please hang up the call and we will change the policy. Okay, now I have set the policy as adaptive. This means that only an audio call will be accepted even if the end user will ask for a video call. Please, let's try to generate a new video call.
Sure. Now with Japper.
We'll see that the call will be set up only with audio.
Hi Andrea.
Stefano.
Hi. So, the call has been set up as audio. And we see from the call admission manager interface that an audio call has been set up. So the call has been admitted, but as audio. So please hang up this call and we will test the last policy. Last policy is strictly. So if there are no resources on the channel, the call will not be accepted. So let's try the behavior of the 2 different clients.
Sure. Okay, now with Zoiper.
Yes, Zoiper will receive a 503 SIP message.
Service unavailable.
Yes, this means that there are no resources, so the call admission manager will not admit the call, sending a 503 to the end user. Now try with Japper, and we will hear a fast busy tone that has the same meaning. Perfect. So we have shown that, and now we see that the counter has increased with the 2 refused calls. So we have shown that with the call admission manager we can manage the quality depending on the channel conditions.
Great demo, Bruno. I understand that with your solution, IT managers can implement a dynamic and centralized call admission control for heterogeneous real-time applications. In this way, they can effectively apply call admission rules depending on users' application needs in the different branches. I'm wondering if it could be possible to integrate Call Admission Manager with an external video scheduling system.
Yes, with this integration, you can provide scheduled resource allocation. Moreover, for the same reason, the solution could be integrated also with trend analysis applications.
Right. I'll come back to my customers proposing this brilliant solution. Thank you, Bruno. Bye.
Thank you, Stefano. See you.